Hello, everybody. I am going to be going through 2018 FRQ number 1, a famous escalator problem. I remember back when this question was given to students, and if you Google calculus escalator, there's some pretty beautiful memes out there, mainly done by the AP folks because they thought this question was extremely challenging. The reason why they thought it was challenging, I think, is because of the piecewise, and there's a lot going on. So I'm going to try to add to my little videos here, especially for the 2020 folks, because you're going to be taking this test online, and I want to kind of highlight a few things that I would do if I was going to be taking this test online. It's not really going to be convenient for you to print these questions and then write on there. So as I would do this problem, I would first of all read it from my screen like I'm doing with you here. People enter a line for an escalator at a rate modeled by this function R. Things that I feel are important, I have my piece of paper with me with my pencil, and things that I feel like that are important is that this R of t function is a rate. So it's very important that you're kind of keeping track of the units. R of t is measured in people per second. So that's something important. Maybe I'd write down, kind of depending on time and how quickly you move through these questions. Many of you probably do pretty fast, but with this year, 2020, I don't know how fast, I don't know how much time you're really going to have on a 25-minute FRQ. But the question does say here that people are entering a line. But then, as people get on the escalator, they also exit a line. So then there's this other rate down here, but this is the exit rate. So you have people going on, people coming off. Question A, how many people enter the line for the escalator during 0 to 300? Well, this piecewise is only valid 0 to 300 in the first piece. So how many people are entering the line? You just care about this entering the line rate from 0 to 300. So that's just an integral. So your integral will give you that first point. And you do have to show setups, and I think that's how 2020 is going to be a little bit different than past exams. It is the same here that, of course, you have to show your setup, but I think that they're going to, because there's so many little devices out there that calculate integrals quickly, they're probably just going to say something like show the setup. They might have you calculate this. I really have no idea, but I have a feeling a lot of questions are going to just say show the setup. And then, of course, this question here, you'd be typing all of this into your calculator here, this 44, the t over 100 cubed, etc. That's going to be a challenging question to enter just to the fact that there's a lot of parentheses going on with fractions and stuff like that, so it shouldn't be too bad. But the bottom line is your answer for this should be 207. So that's how you get your second point. Moving on to part B. Part B says, during the time interval 0 to 300 again, there are always people in the line for the escalator. How many people are in the line at this 300 point? One thing I do want to talk about real quickly is somebody made this mistake the other day. When you're calculating a derivative or a slope, don't forget to divide these two units. So if I was doing a derivative or a slope, or an average rate of change, which is the same as a slope, I would do people per second divided by seconds. So it's people per second squared, or people per second. Now, if I was integrating this, then I would be multiplying these two, and the seconds would cancel, and I just get people. So kind of remember that. That's something I always go through. I always do a lot of my questions from the unit perspective, looking at the units and comprehending. Another good example, or something that I would do in the 2020 exam, is I'd kind of write this little sketch down because I'm keeping track of two rates here, and that makes a lot of sense. So one more time, people in line. So starting off, there's 20 people in line. So that's this green little marking here. Then people are coming in, that's the enter, blue underline, versus coming off, that's the purple underline. So if you take an integral of the rate in minus the rate out, a very common rate question, then this whole piece right here is going to give you the total people that, entered that line total when that got on the escalator, I should say. And then that's kind of keeping track of the people getting on, taking away the people that are getting off. Very common rate. Remember the Sandy Beach question? Sand was coming on the beach, sand was getting washed away from the beach. These are very popular. Not sure if they'll be on 2020 with only 2 FRQs, but something to take note of. So now a lot of students forget to consider the rate out. So that's this 0.7. So you really have to kind of keep track of that. Now this 0.7, when you integrate it, it's going to be 0.7t. So 0.7t, if you plug in a 300, it's going to be 0.7 times 300 minus 0.7 times 0. So a lot of students will just kind of do this without using an integral, which is perfectly fine. So either one of this expression or this expression here is going to give you that consider the rate out, because here's the rate out here, and here's the rate out here. But then the answer is the most important point here, and then you kind of work all this out using your calculator, of course, and you get the, just a quick summarizing statement, which you don't really need as long as you have all this. Part C. From greater than 300, what is the first time t that there are no people in the line for the escalator? All right, so based on the number in part B, this is part B's answer right there. There were 80 in line, going back there for a second. There were 80 in line total. There were 80, how many people are in line with 300? There are 80 total there. So for this part, you have this 80. Now, what's the first time there are no people in line? Well, there's this 300 number here. That's the seconds. But then you want to know after 300, and that's where this part comes into play. So after that 300, no people are entering. However, you still have people exiting the 0.7. So if you take 80 divided by 0.7, this is going to give you the time it takes, for all of those people to come off. So I put a little analysis over here to kind of make sense of it. So if I have this 80 people from part B that are in that line, and then 0.7 are coming off, if you divide these two, people divided by people per second, if you multiply by the reciprocal of this, people divided by people per second, which will be people times seconds over people, the people will cancel. That'll give you a time. So you have this 300 original time, and this right here, the result of that is going to give you the time it takes for all of those people for the line to go down, I guess, is the best way to say that. So once you calculate that, because now you're talking about this is seconds, and this is seconds, and this is going to be your total seconds, it's going to be this answer here. Now the question only has a point for the answer, so it's not that huge of a deal. You're just looking for this to grade. But a lot of students don't understand why or how this all works, so that's why I tried to do a little bit more explanation for you. And then comes part D. This is going to be candidate test. So from 0 to 300, what time is the number of people in line and a minimum? Doesn't say absolute minimum here, but that's kind of implied. To the nearest whole number, find the number of people in line at the time and justify your answer. So we need to kind of figure out how many people are kind of total in line. So there's 20 people at the start, you got your 20 here. And then you're accumulating more people. This is kind of like that first one, you went from 0 to 300. But the problem is you don't know that ending time. So it's an unknown t up here in your upper limit of integration. And then you still have people coming off. So don't forget your rate coming on minus your rate coming off. This gray part is the same. Some people will choose to put 0.7 in there. Some people will choose to integrate this because it's really easy. 0.7 integrated is 0.7x or 0.7t. And then you plug in the t, plug in your 0, and then subtract them, you get this. So you get this. So you could have left them in there like this. You could have left them in there like this. Do not get hung up on these letters. Well, how come there's an x here and then there's a t there? They usually don't have the same letter here and here, and you really want your result to be time. So ideally, it's this ending time that goes in your upper limit, and then you should just change these letters so they're not the same. They will still give you points for that if you put T's in all of these spots, but it doesn't really matter. So now the question is, how do you get a maximum? The maximum happens in total people in line, when the derivative of the line, the rates, which are already given to you, here are your two rates, rate in minus rate out is equal to 0. So you had to kind of figure out that answer. Those answers are 33.013 and 166.574. Now, if you have those two answers on your paper, you're probably going to get this considering point. Please don't forget, especially in 2020, you should show your setup. This is how you find the maximum. If you're finding the maximum of total people, I don't know if this function looks like this, it does not, but if you're finding ever a maximum, you want the derivative to be equal to 0. Derivative is a rate when you're asking for maximum people. You want to do the people per second. So that's the rate problem equals 0. These are your critical points. Absolute minimum is candidate test along with your endpoints. So now, once again, if you identified this, 33.01, that's going to be your critical point. So if you have that somewhere on your paper, that's going to give you that second point. And then your answer is going to be the number of people in the line is at a minimum of that time frame. And it does say, to the nearest whole number, find the people in line. There are going to be 4 people in line at that time. They didn't show a lot of work for that. They didn't show any work for that. But basically, if you got that 33 point, well, okay, here it is. Yeah, there's 4 people. Sorry, my bad. So this is where there are 4 people in line, round to the nearest person. So that's going to be your local, your absolute minimum from that 0 to 300. How do they get 20 and 0? That's given. How do they get 80 and 300? That's from part B, considering your endpoints. This justification point is always tricky. If you look for absolute minimums and maximums and you just do a candidate test and you do a table or a chart or something like this, you're going to get all that credit. If you didn't do this and you just said, okay, well, there's a maximum at 33.013 because the derivative or these rates change from positive to negative, therefore giving you this maximum like this here. I'm sorry, this would have been reversed to minimum. So it's really not looking like this, it would have been looking like this. But then this is the absolute minimum because it's 3.803 people that are in line. But these are kind of your unknowns. This is a very tricky candidate test question. One of the hardest ones I've ever seen, but I hope it all makes sense to you. It's pretty challenging. And then your justification is definitely a long sentence explaining this and discounting the endpoints. Particularly if you look at the graph, you really need to make sure that that interior endpoint here is less than this. This interior endpoint is less than this endpoint is less than this interior endpoint. I'm really rusty. Sorry, it's been a long time since I've seen you guys. I hope that makes sense. Thanks for coming today. Good luck. I miss you all.